here we go, guys. This video is going to cover the second part of content for today's class, which is 5.4 in the text, properties of midsegments. Okay, as it says here, right, if we take the midpoints of two sides of a triangle, right, and we connect them, it's actually called a midsegment. Okay, you can also do the same thing with a trapezoid. All right, it's the same idea. Take a midpoint of a side, with two sides really, and then connect them. All right. First conjecture here, the three segments conjecture, the TMC. If you take three segments of a triangle, what happens? Okay, and you can look here. Might not be clear, but you've actually got four congruent triangles here. So these are all congruent. They're oriented the same way. And then this is congruent to all those as well. Okay, so what can we say with this TMC? The three midsegments of a triangle divided into four congruent triangles. They're congruent to each other, obviously not congruent to the original. All right, so let's write that up. Let's try it again. Let's write that up. Oh, got to open it here. Okay. So, make a new section here. How to do it before. 5.3. All right, so this is 5.4 now. 5.4. Mid-segment. Actually, I'm going to let you guys fill that in. Defined as, all right, but we can't talk about the properties of a midsegment if we don't know what it is. So be sure that you are comfortable with what a midsegment is. Three midsegments conjecture. So the TMC. The TMC. Yep, just checking that I'm doing the same thing with the colons. Okay, so the three midsegments of a triangle divide the triangle into four smaller, I'm going to add smaller, congruent triangles. Okay, probably don't need the smaller. It's pretty clear that if we take a midsegment, we're making, if we connect a couple midsegments, we're making a smaller triangle, but I don't know, I'll put it in there just for extra emphasis. All right, so that's the first property. Second one, the triangle midsegment conjecture. A midsegment of a triangle is blip to the third side and blip the length of blip. Okay, well, it's probably what you think. Might not look like it, but this is actually half of this lengthwise. Okay, if we were to draw a line right there, those lengths are equal, and that's half of that. Okay, so this says the midsegment of a triangle is parallel to the third side. You know, we can kind of see we've got these corresponding congruent angles, right? And it's half the length of it. So the TMC. Oh, TMC2. So maybe we put this little s in here. This is the midsegments conjecture. TMSC. And just the straight singular TMC says the mid-segment that's bad language. Let's get rid of this D. A. That's better language. A mid-segment. Let's zoom in a little bit. Just a smidge. Okay, a mid-segment of a triangle is parallel to the side. I think the book says third side. Yeah, I'm going to say the side it does not connect to, or third side. To the side it does not connect to. This is also called the third side. Okay? It's parallel to that side, and it is half the length of that side. Okay, so maybe we draw a picture here. Triangle. Okay, midpoint. Approximate midpoint. There's the midsegment. All right, maybe let that refocus. Okay. So yeah, if this is A, it's hard to see, but it's true. This is A over 2. Okay, and these guys are parallel. And while I'm marking it up, let's do this. That's a midpoint. Those are congruent, right? This is a bad idea. These are congruent. All right. But nice property about midsegments. Okay, guys. I believe that's it. And I believe I lied. Okay, we've got one more. Trapezoid midsegments. Midsegment of a trapezoid is blip to the base is equal in length to blip. Okay, so let's call that, geez, that's also the TMC. I'm going to call that the trap MC. Trap MC. Trap. Trap MC. Well, it's parallel to the bases. Okay, that part's clear. The midsegment of the trapezoid is parallel to the bases. Right? Remember, in a trapezoid, let's go back. In a trapezoid, the bases are going to be parallel. Okay, so if we construct this midsegment, it's going to be parallel to them also, right? The equal length is a little bit trickier, right? So it's actually, geez, this midsegment is longer than one base, but it's shorter than this other base, okay? And what it's equal to is actually the average of these two bases, okay? So it's equal in length to the average, which means we add them together and divide by 2. Kind of cool. This picture is nice. This actually shows a triangle, right? This base is zippy, 0. This base has some length, MD. The length that's going to equal half of this plus this, but this plus this is equal to this, because this is 0. So in a triangle, this is equal to half of the one base. All right? The second part of this, it's equal in length to the average length of the bases. Average length. Parallel to the bases and equal in length to the average of the two base lengths. I don't know if I like my wording there, but you can change your own if you want. Okay, so let's draw a picture of this too. It's got a little bit of space of paper left. So here's a trapezoid. Okay, I'm just going to freehand it. This is not what we really want to do, but for what we're looking at right now, it's okay. So these are all parallel. Okay. If this base length is A, right, and this base length is B, then the mid-segment length is going to equal A plus B over 2. Okay, it's the average. So there you go. I think we've covered all the properties in 5.4. Let's just double check that. Yep, looks like we got everything. Okay, so I'm going to end this video, and you've got some homework to look at from 5.4. What is that homework? It's 1 to 9. 1 to 9. Okay, so you got one proof at the end and one construction at the end. So have fun looking at these problems, and we'll see you next class.